The first and most reliable way to fly is to let imagination soar. In the beginning, flying was something for adventurers to do on a dare. Dreamers, pioneers, aviators and resourceful scientists set a course for air and space flight far into the future. Passion, unique discoveries and awe-inspiring inventions set the standard for the vision of flight. Preparing to make that first big leap required the acquisition of a bit of avian know-how. It all began with the bold quest of an engineer from Berlin, Otto Lilienthal. Lilienthal took to the air with hang gliders he made himself. The flights were short.
Lilienthal wollte herausfinden, was ist der eigentliche Grund.
Lilienthal wanted to find out exactly how birds flew, so he watched them.
Durch Naturbeobachtung gemacht, also ein wissenschaftlicher Ansatz.
Using a scientific approach, he augmented the observations with his own experiments. That's what predestined him to become the first researcher to explain how propulsion worked. Until then, it was a real riddle.
Erklären zu können, das war vorher ein großes Geheimnis.
Experimentation was ascending. Lilienthal studied the characteristics of birds' wings, such as storks, for example. Observation led him to make a key discovery. Storks' gently arched wings produce the lowest resistance and the greatest lift. Lilienthal was laying the groundwork for new invention. Flight was merely a step away. Taking off into the wind worked, just as it did for birds. In 1891, Lilienthal flew 15 meters. Soon he was making flights of up to 300 meters, until August the 9th, 1896, when he fell to his death, probably trying to best his own record. In 1900, Imperial Germany is bustling. A technologically advanced great power, the tap of the telegraph revolutionizes communication and sets the beat for Germany's spin through the exciting days of the avant-garde. Rail lines link one corner of the country to the other. And the gramophone is popular. In the coming years, 23 Nobel Prizes are awarded to German scientists. Car racing becomes all the rage. And Count Ferdinand von Zeppelin is soaring high above Lake Constance. The conquest of the skies is starting. In 1907, the Model Airship Testing Institute is set up at Göttingen. The first institution devoted to avian research is equipped with a closed wind tunnel, designed to investigate the problems of flight. An electrically powered fan is used to generate a current of air inside a large tube. Motors and propellers are designed and specially made for the unique piece of testing equipment. The wind tunnel is the first of its kind and marks a milestone in the history of this type of testing technology. The first experiments are carried out under conditions of controlled airflow.
Damals war das noch nicht primär auf Flugzeuge bezogen.
At the time, airships rather than planes were really the passion of flight enthusiasts.
Man muss sich vorstellen, also Luftschiffe.
At the turn of the century, Zeppelins were already a recognized means of air transport.
Das Verkehrsmittel durch die Lüfte und man wusste.
But there was little knowledge of aerodynamic laws.
Sehr wenig.
What was the shape that would optimize the movement of an airship through the air?
Sich optimal durch die Luft zu bewegen.
The real work begins with the first measurements, which are taken after a turbulence-free airflow, suitable for experimental purposes, is successfully generated in the tunnel. Among the data recorded are drag, airflows and pressure distribution. The optimal shape for an aircraft remains a mystery. Airship designer August von Parseval is the first to commission the Institute to investigate and develop ways to improve the airworthiness of his craft. Pasewalk draws attention by making experimental flights that are longer than 1 hour. On the eve of World War I, Germany leads the world in the development of dirigibles.
Luftschiffe vor 1910, die waren ganz unterschiedlich.
Before 1910, airships were built every which way. Some were pointed at the prow, others at the stern. Some looked like cigars. There were long ones, short ones. Every possible shape and size were represented.
Nach den Messungen in Göttingen,
After the data were gathered and assessed at Göttingen, all the world's airships looked the same. They were slightly rounded at the front and gently pointed at the rear.
sanft zugespitzt.
Balloon races become fashionable. The controversy over whether something heavier than air will ever fly begins in earnest. The dispute does nothing to dampen spirits. Aims remain high.
France had a head start when it came to aviation research. Germany had to catch up and managed it with the help of people like Count Zeppelin. So heady was his reputation that it was lighter than air. Based on this and a wealth of experience, he became the person who set the tone for the future and can be credited with putting the study of flight on an institutionalized scientific footing.
Motorized flight is not far off. After thoroughly studying Lilienthal's work, 2 American designers, the Wright brothers, become the first to make a motorized flight in 1903 in a craft that is heavier than air. Many are willing to risk life, limb, and becoming a laughingstock in experiment after experiment. Often their contraptions do everything but produce the desired result. The idea of flight sends the fancies of dreamers, inventors, and serious aficionados soaring, leading many of them to be scorned by others as visionary lunatics. In 1904, the hydrodynamic engineer Ludwig Prandtl makes a startling discovery that revolutionizes the up-and-coming new science of aerodynamics. He describes the boundary layer, where all airflow changes occur. The discovery brings Prandtl recognition from all over the world, including Russia and later the US. Then, in 1909, Prandtl is made the world's first professor of airship flight. His scientific writings, such as the wing or lifting line theory, create a huge stir and become one of the key cornerstones of aerodynamics.
Also die Grenzschicht ist die Schicht,
The boundary layer is in immediate contact with an object's surface.
direkt an der Oberfläche haftet, aber sich
The greater the distance from the surface, the more the layer conforms to its surroundings.
der äußeren Umgebung angleicht. Also mathematisch
Considered mathematically, the boundary layer is a bit of a simplification. Ludwig Prandtl applied this trick in 1904 to calculate and describe numerically currents along the surfaces of different objects.
entlang von Körperoberflächen mathematisch behandeln zu können.
Scientists of aerodynamics meet at the world's first aeronautics congress in Göttingen in 1911. It's one of the first times that the benefits science could have for aviation are discussed in an open scientific forum. Aerodynamics and the mechanics of flight are addressed. In the same year, a student of Prandtl's, Theodor von Karman, publishes his theory of vortex streets, the swirling motion of gases behind an object after they've moved over it. Air shows are the latest diversion. To get their thrills, Berlin residents flock to the quiet suburb of Johannisthal on Sundays. In 1909, flyers, the obsessed and tearaways give excited spectators the show they want to see in the skies above one of the first German airfields to feature motorized planes. Even the Wright brothers are buzzing Europe. Crown Prince Wilhelm, here speaking to Orville Wright, is impressed. On some days, more than 500,000 viewers attend. Aviation pioneers began to pit their homemade machines against each other. Fortunes in prizes go to the fastest flyers. The imperial court and industry offers stakes as high as 40,000 marks in gold.
During the early years of flight, progress came as a result of trial and error. You built a plane knowing it needed an undercarriage and 2 wings. But beyond that, everything, considerations like how fixed the wings should be, or what would create the least drag, was a big grey area, nebulous and unknown.
Grau, nebulös und unbekannt.
Everyone was tinkering around in their workshops and sheds. Mechanical skill became the means to pursue the dream of building a flying machine, but without any scientific qualifications. They simply made contraptions and then tried to see if they would fly.
Clattering flying machines have their charms. French, British and American inventors stole the show from the German aviators to begin with. The spirit of flying competitions was still sporting, but only just.
Early on, there were n number of experiments, meaning there were countless. There were planes with the engine in back, some had 5, 6 or 7 wings. They tried everything. The times were creative, and nobody knew exactly where it was all heading. Anyone was free to experiment, but the risks were high. Attempts to discover if their ideas really worked cost many early airplane builders their lives.
Aviation pioneer Hans Grade moves Germany back into the spotlight by winning the Lanz Aviation Prize in 1909. The triumph helps the country regain ground Germany needs to make up. To win, Grade had to fly a horizontal figure of 8, some 2.5 kilometers in length. All parts of the aircraft had to be from Germany, and the plane's builder and pilot had to be German as well.
The technological leaps were spurred by ready cash. Germany had registered that aircraft were being built in all the neighboring countries. Even France, known to some as the hereditary enemy, had already built many planes. But us, we didn't have a thing. It's a simple technical fact, understood by every engineer and scientist. If the money's there, then research will progress. Soon there was discussion about whether the entire development shouldn't take place under the auspices of a larger scientific organization. A scientific institution had to be set up to address these questions, which had previously been tackled by in-flight experiments.
The German Aviation Testing Facility, or DVL, is set up with the signing of a certificate in 1912. The compound at Adlershof becomes the Aviation Research Center of the nearby German imperial capital, Berlin.
In 1912, they began to build research institutes at breakneck speed. Not just hangars and airfields, but wind tunnels and testing rigs for engines with all levels of horsepower. A large concentration of research hardware and personnel were located here. That did nothing to impede synergies with other research establishments, while it remained a place where one could work relatively independently.
A veteran aviator and airship pilot, Major Georg von Tschudi, becomes the director of the nearby airfield at Johannisthal. The landscape of the Mark becomes a home for departments engaged in researching the physics and technology of flight, in addition to the site for a number of test rigs. Engine overheating plagued the early years of flight. Some of the best-known aircraft makers of the time settle near the gates of the DVL compound to improve their craft through systematic application of scientific research and establish a link between industry and research. The military expresses its interest as well. War breaks out in August 1914. Planes become weapons for generals to deploy. More maneuverable, faster, and with a far better vantage point, the aircraft replaces the cavalry as a reconnaissance tool. Contemporary heroes are Immelmann, Bölke and Udet. The day of the elite fighter pilot dawns. Conquering the skies is taken literally. Research is now done in the name of war. Fighter production begins and the first one-seater planes delivered to the front. Men like Manfred von Richthofen, the Red Baron, fight their way to fame and fortune. The age of the flying ace has arrived. Bombers and gunships are built and increasingly deployed against strategic targets. New plans are made to build a larger research compound equipped with bigger wind tunnels. In 1916, a model testing establishment for aerodynamics, the MVA, is built in Göttingen.
Im Ersten Weltkrieg
During World War I, military resources were used to drastically enlarge the research establishment at Göttingen.
mit Mitteln des Militärs und ein
A much larger wind tunnel was built there, and in both the small and the new, larger tunnel, a series of experiments were carried out on wing cross-sections, airfoils.
Vielzahl von Tragflügelprofilen im Windkanal vermessen.
Seen from an empirical standpoint, this was the start of the scientific study of aerodynamics.
Aerodynamic.
The new tunnel is state-of-the-art, a model for similar testing facilities the world over. It produces wind speeds of up to 180 kilometers an hour and lends its name to all subsequent wind tunnels like it, the Göttingen type.
Im Göttinger Windkanal
A number of airfoils designed and developed by different aircraft makers were tested in the Göttingen wind tunnel.
Diese Flügelprofile wurden in anonymisierter Form
Results for the different airfoils were published in anonymous technical reports, so that one manufacturer wouldn't know what another competitor had developed.
der jeweiligen Flugzeughersteller nicht erfuhren, was ihre jeweiligen Konkurrenten so auf Lager haben. In Göttingen hat man diese
In
Profile
Göttingen, they simply numbered the airfoils and tested them, and some of their own different designs, sometimes varying them slightly.
variiert und
They then recorded the aerodynamic data.
festgehalten.
During the First World War, the data were stored in files that were either secret or accessible solely to the manufacturer that had created the design.
Und Forschern zugänglich waren, veröffentlicht.
Wing templates drawn up at Göttingen become the industry standard for decades to come. Anyone, anywhere in the world who wants to build an aircraft uses them as a guide. The name Göttingen goes down in aviation research history. Testing wings by loading them with sand sacks and 42 troops leads to the development of a new branch of research, aeroelasticity. A model train pulls a test rig in the Göttingen wind tunnel. A life-size version of the experiment is conducted later, south of Berlin, on the military railway between Zossen and Jüterbog. Later, south of Berlin, on the military railway between Zossen and Jüterbog. Engine and propeller test rigs run on rails. Assessments are conducted under outdoor conditions, similar to those faced by an aircraft in flight. Aerodynamic shaping of wings, fuselage, propeller and other parts of the plane, certain types of engine are the scientific fruits of World War I.
If you consider the change in the look of planes between 1914 and 1918, it really becomes clear that a major leap had taken place. 1918 vintage planes flew considerably higher, were faster, and could carry greater loads, bombs in this case. By the end of the war, plane designs and technologies had, like a good wine, matured and improved with age.
Fokker builds the first one-seater monoplane fighter, and Hugo Junkers makes the prevalence of wood as a material for building aircraft a thing of the past when he builds the J-1, the world's first metal plane. But aviation progress did nothing to avert Germany's defeat in the war. The armistice was signed on November the 11th, 1918. The 1920s roar into life as Europe recovers from the war. Everything is new, exciting and ever so modern. It seems the whole world is a big dance hall. But in the Treaty of Versailles, the winners of the war hand Germany the bill for its earlier aggression. The country's aircraft are scrapped. What the Allied forces, Britain, France and the US, don't need is decommissioned, dismantled and destroyed. Even aircraft engines end up on the scrap heap. Soon the hangars are empty. German aircraft are never again to be used to wage war. Competitive German plane makers are closed down. But the setback becomes a turning point. Now experiments in Göttingen are focused on completely different models. The streamlined Rumpler Tropfenauto is tested in 1921. Though it's more than 6 decades ahead of its time, the low wind resistance multi-passenger car is never mass-produced. The express train is also subjected to the artificial stream of air, and drag measurements are taken for Daimler racing cars clad in streamlined hulls. The cars later reach speeds of 190 kilometers per hour. The wind tunnel is also used to prepare initial designs and prototypes for gliders. The aviators have found a loophole in the restrictions placed on them by the Allies. The Treaty of Versailles mentions motorized flight only.
Wir dürfen nicht mehr fliegen.
What do you mean we're grounded? Impossible. The ban on motorized flight in the Versailles Treaty led to the start of a great new development in aviation, the glider. Aficionados and experts met on the Wasserkuppe. Looking at these contraptions made of nothing more than wooden spars and stretched cloth, it's really amazing that they actually flew some 200 to 300 meters and stayed up in the air for a minute or two. Sometimes banning an activity can have unforeseen effects that have little to do with the ban's original purpose. While one activity is stamped out, something else springs up in its place.
Gliding is the sole option left to Germany's aviators. But by 1920, they are already holding the first gliding competitions in the skies above the highest peak in the Rhön Mountains, the Wasserkuppe.
The project in this case was to develop aerodynamic specifications for gliders. A scientific foundation for soaring was to be laid that would address meteorology in particular and the knowledge of air currents, which are both key to gliding for long distances. This clearly demonstrates how gliding became a vital component of aviation research.
A short time later, German pilots are able to resume powered flight. Mail and passenger services are among the first to take off. The first airlines are opened. Dornier builds its famous flying boat, the Wal or Whale. The plane makes history when in 1926 it becomes the first aircraft to cross the South Atlantic. The Junkers F-13 becomes the first passenger aircraft in the world to be built out of metal. With it as a workhorse, the newly established German airline Lufthansa gains preeminence in the skies. An unintended consequence of the Versailles Treaty is that Germany is able to successfully build planes that are aerodynamically superior, because they may only be powered by relatively weak motors. In 1924, construction begins on the new building at the Kaiser Wilhelm Institute in Göttingen. Since 1920, the MVA has been known as the Aerodynamic Testing Facility, or AVA. Plans are unveiled in 1928 for another wind tunnel. The measurement area is to be 4.5 by 7 meters in size, one of the biggest of its kind at the time. A few years later, the first specialized wind tunnels, able to generate wind speeds in excess of 900 kilometers an hour, are built. Adlershof has been equipped with additional motor and propeller testing rigs by the end of the 1920s. The facilities are also used to assess the airworthiness of aircraft in a sort of standardized MOT for planes. Dressed in an elegant suit, Leslie Irving came all the way from Buffalo, New York to test his air-chute or free-fall parachute. After tests at Johannisthal Airfield, the new invention was certified safe in 1929. During World War I, flyers rejected parachutes as being beneath their honor. But by 1930, they were being used by more than 40 air forces. By September 1930, a group of imaginative, innovative individuals cause a commotion by taking aim at the stars. A group of pioneering, daredevil, enthusiastic hobbyists begin carrying out dangerous combustion experiments with liquid-fueled rockets. Ranging from visionary to crackpot, they're united in the hope that they will soon send rockets into space. The former parade ground in Berlin's Tegel district becomes the proving ground for these completely unpredictable flying objects.
The idea of interplanetary spaceflight wasn't just being bandied about, it was extraordinarily popular. There were big fan clubs with large memberships and comprehensive literature that from a cosmic standpoint was actually very far-reaching. Flights to Mars were discussed, as were types of satellites that we can't even now imagine. They were visionaries.
They fire more than 100 rockets into the skies above Berlin. Known sardonically to some as the Tegel Fools, these hobbyists are setting the foundations for space travel. Rockets were an ersatz for the loss of national and government power. Leading German scientists were thinking about spaceflight. The title of Hermann Obert's trailblazing work showed where things were headed, the rocket into interplanetary space. There were loads of rocketry clubs, amateur rocket builders associations. Rocket mania was widespread among the general population. Fritz Lang's films were right on target. Rockets were the thing in Germany in the 1920s. Opel's rocket car was another example. This enthusiasm was something scientists could build on. People everywhere seemed crazy about rockets, not only in the skies over Brandenburg, but on the road. Even one of Germany's greatest automobile makers of the time, Fritz von Opel, wants a piece of the action. The physicist and spaceflight pioneer Max Valier conceives of a car capable of explosive speeds, and Opel is to drive it. Forget the engine, the popular Rack 2 is powered by 24 solid rockets. 3,000 excited Berlin residents come out to see a test drive. The show is short and sweet. The trip takes 2 minutes, with the Rack 2 reaching speeds of 200 kilometers per hour. There are demands to step it up a notch. Designers produce a rocket-powered car on rails, but they daren't ask anyone, not even Fritz von Opel, to drive it. A cat is placed at the helm. Some 300 kilograms of dynamite go off with a big bang. For the record, a comforting note says that the cat survived with minor injuries. One young Berlin rocket man is going to make a name for himself in the future. Werner von Braun's career begins when he takes a job at an experimental site in Kummersdorf, south of Berlin. It's 1933, and preparations for the military use of rockets is getting underway. Commissioned by the Office of Military Armaments, the task was to test rocket engines for use in missiles. Air travel gets a majestic boost when an aircraft, the Dornier Doe X, becomes the pride of a country crazy about flight. The world's largest aircraft, the colossal plane seats 160 passengers. In an unparalleled triumph, the technical wonder arrived in New York City from Germany on August 27, 1931. The Junkers W-33 also rose to fame when it crossed the Atlantic. Some say it's flight's golden age, highlighted by many new designs and developments, such as the Junkers G-38. Germany is again the mecca of aviation research. Experiments are promoted by the state, but science retains its independence. An enormous concrete egg is built in Adlershof. It's a vertical wind tunnel to be used to assess what forces do to an aircraft in a spin. It's also to help determine what causes planes to crash for seemingly no reason.
These were tough times for aviation. The technical possibilities of flight went far beyond human capabilities to control them. So it was decided to set up scientific establishments where it would be possible to investigate scenarios under controlled laboratory conditions before disaster struck. That's why they built the vertical wind tunnel, to learn more about the dangers of the flat spin.
The ground is rushing up on a free-falling plane. DVL test pilot Richard Perlia is in the cockpit. It's up to him to experience the reality of the dangers of a flat spin.
I was really fascinated by flat spins. You usually couldn't get out of them. I flew a Messerschmitt Me 31 with low-slung wings. It was filled with lead pellets for the test. When I reached 3,500 meters, I was to take my foot off the gas and pull the stick back as far as it could go. That really went against my instincts. Then I was supposed to hit the rudder. I always sat on the left, even in the two-seaters. The plane went into a real flat spin. 18 spins were planned, but after 11 full turns I was getting a little dizzy. So I looked down and picked out houses and a church tower. Then I started to count, 11, 12, 13, up to 18. That was it. I was supposed to pull out hard. If I'd moved the stick the wrong way, I wouldn't be sitting here now. The worst thing was that the stick kept jumping around like an electric mixer. It was as if the rudder was no longer there. That's a flat spin for you.
Progress is also made in the development of rotor-driven aircraft. On June 26, 1936, the world's first fully controllable helicopter, the Focke-Wulf FW-61, makes its maiden flight. On the fourth try, it remains airborne for 16 minutes. Buildings are going up everywhere, in Adlershof, in Göttingen, and starting in 1936 in Braunschweig, where the German Aviation Research Establishment, DFL, is being set up. The wind tunnels here have awe-inspiring dimensions. Some are up to 14 meters in diameter. Wings and even entire full-scale aircraft can be tested here. In 1935, Germany unilaterally withdraws from the Treaty of Versailles. During this period, nearly 30 million Reichsmark flow into research. Scientists are to draw up new specifications for larger planes with more powerful engines. High-speed and high-altitude flights are on the agenda. Germany has some of the most modern aviation research facilities in the world at its disposal.
The big wind tunnel was for slower planes. During the years it was being built, it was planned to generate airspeeds of up to 65 meters per second. That's a little over 200 kilometers per hour. Those were normal flying conditions for passenger and transport planes. And the tunnel's large diameter, 14.5 meters at its maximum, made it suitable for testing life-sized models, which produced excellent results.
Research gets underway on a large scale. By the end of the 1930s, several thousand people are employed in German aviation research. Europe is getting smaller. A flight to Rome takes just 10 hours. The Junkers Ju-52 becomes the epitome of a mass-produced aircraft. At 5,000 planes, it's the most frequently built plane of its time. Trademarks like metal construction and low-slung wings make it one of the most modern, robust and high-performance aircraft of its time. Scientists in Göttingen get involved in the study of a mysterious phenomenon known as flutter, which destroys wings and parts of a plane's stabilizers, elevators and rudders at high speeds. A Ju-288 is put to the test in Braunschweig and a He-219 in Göttingen. The result is the discovery of new ways to prevent flutter that are still applied in building aircraft today. Test flights for Project X get underway in 1938. The revolutionary new plane is propelled by a rocket. After a series of setbacks, the first rocket-powered Messerschmitt 163s take off in 1941. The fighter's design incorporates aerodynamic wings that are a decade before their time. They were developed on gliders being flown while Germany was still subject to the restrictions set in Versailles. At that time, the plane's speed at takeoff was unimaginable. The Mir 163 is what's called a flying wing aircraft. It's capable of flying almost as fast as the speed of sound. In Germany, designers like Lippisch and Horten favoured flying wing aircraft, or planes without a fuselage. Their visionary drafts date back to their gliding days. The National Socialists have been in power since 1933. Military research has top priority. A model of the first German aircraft carrier, the Graf Zeppelin, is tested in one of the wind tunnels at Adlershof. Poorly designed, the vessel is never deployed in a military action. More new planes are in the sky. Flight gathers new impetus. The Mir 262 is the first operational turbojet fighter aircraft. By 1938, Hans von Oerhain has already developed the world's first turbojet engine. A German scientist, speaking at the Volta Congress in Rome in 1935, introduces a revolutionary theory concerning lift when flying at speeds greater than that of sound.
A German professor from Göttingen, Adolf Busemann, attended the Congress, but his presentation drew little attention, even though he told his colleagues how to design a plane capable of flying at supersonic speeds. Wings attached to the fuselage at right angles had to be scrapped. Instead, the wings had to be angled back and became known as swept wings.
Aircraft wings must be redefined. The theory represents an aerodynamic breakthrough that is still being applied today. Swept wing designs for high-speed aircraft are tested in the wind tunnel, and patents are filed for ground-adjustable wing sweep, which was invented in 1939. Science is getting ahead of its time. The idea of modifying wing sweep comes too late for the first generation of turbojets, and too early for the second generation.
It soon became clear that there was no way to outgun the three great economic superpowers, the Soviet Union, Britain and the United States. We figured we had only one chance, and that was to use quality to make up for our quantitative deficits.
The search for a means to counter Allied air superiority begins. Engineers develop the Fiesler 103, an unmanned flying bomb steered by a guidance system. The world's first cruise missile is called the V-1, with V standing for vengeance weapon. The missile brought destruction and suffering to many. Different generations of guided missiles are tested in the wind tunnels. Between 1936 and 1945, Germany becomes a center for the development of air and space flight technologies that continue to impact both civilian and military aviation well into the second half of the 20th century. One of the most ambitious projects at this time is the development of a ballistic missile, the A4. The rocket is 14 meters tall, weighs 14 tons, and can generate 25 tons of thrust. To promote the project, the Third Reich's most expensive and elaborate, a top-secret program is initiated at Peenemünde on the Baltic coast. A previously unimagined research facility and rocket factory are set up. More than 6,000 scientists, engineers, and 13,000 support staff begin working to achieve the dream of putting a rocket into space. But at the same time, they're building a new weapon that will fundamentally change the way wars are waged in the 20th century and beyond. Breakthroughs are made in the key technologies of electronics, radio, guidance, and stabilization. The A4's engine is 17 times more powerful than those developed before it.
They built enormous research complexes that had thousands of staff members. You could certainly say it was big science. For the sake of efficiency and to carry out all the tasks set them by the aviation industry, 3 8-hour shifts kept the place running round the clock. In the gargantuan weapons building complex that Germany had become in the 1930s and 1940s, the demand for aircraft and materials tests was huge. The day of big science had arrived.
Progress is also being made again in the wind tunnel. Air speeds of Mach 4.4 have been generated to set a new world record. In 1941, an A4 prototype is set up in a test rig. Werner von Braun combines scientific excellence with diplomatic skill when dealing with politicians. But he's also an opportunist. Sending rockets to the planets is a dream. The V-2 missile some describe as a wonder weapon is a necessary means to achieve that end. Von Braun never expresses ethical reservations, even when prisoners of war are used to build the missiles. The military testing facility is a highly efficient research center. The key to its success is everything under one roof. The close ties between the state, research and industry become an example for major scientific projects in the future.
Today you can objectively say that German research and development focused not only on building rockets, but on establishing the scientific principles of spaceflight, from aerodynamics to guidance. By thinking all the data through, Germany had already developed more advanced concepts. In America and the Soviet Union, rockets were being built, but only on a selective ad hoc basis. Until 1945, only Germany conducted a consistent aviation technology development program. You can say that at this time, we were really far ahead of all the others. You can emphasize that without being presumptuous. It's a fact on which today's experts from the East and the West agree.
After 7 years of work, the first A4 rocket is successfully launched on October 3rd, 1942 at Peenemünde. It's the first time engineers have been able to send a rocket some 100 kilometers into space. The space age is dawning. But Peenemünde is also a symbol for the darker side of science. Some 30,000 prisoners die building the rockets, and 5,000 more are killed when they're deployed. Germany's misuse of the fruits of its fascination with flight comes back with a vengeance. But the country lives to fly another day. A decade later, Germany returns to the echelons of international air and space research. Flight added new dimensions to daily life. It changed perceived limits of time and space. Just a few decades after ingenious and intrepid pioneers of flight tried their luck with contraptions made of slats and sailcloth, engineers had mastered the art, applying complex technologies to build aircraft and rockets. But that was just the beginning. The conquest of the skies continues. French, American, Russian and British troops marched shoulder to shoulder through the Brandenburg Gate in Berlin in 1945 for the first and the last time. Historic events were also taking place in Potsdam. The trio of leaders known as the Big Three, Winston Churchill, Joseph Stalin and Harry S. Truman, sat down to redraw the map of Europe at the end of World War II. They put on a show of harmony for the camera. Germany is in ruins. Air and space research is prohibited. The German laboratory for aviation at Berlin-Adlershof is dismantled and carted off to the Soviet Union in pieces. The British take the wind tunnels in Göttingen home with them, and the Americans and French harvest the fruits of victory as well. Allied planes have sovereignty in German airspace. Liftoff after the war. Researchers prepare to launch A-4 rockets in the deserts of Arizona and New Mexico. The race to exploit German know-how begins. The top-secret US Special Mission V-2 ships 100 German missiles and 14 tons of documents. The archive from Peenemünde.
We in the United States and of course in Britain and France and the Soviet Union all inherited this wealth of new research that had been funded in the late 1930s and in the early 1940s in Germany.
The cornerstones of the spaceflight and rocket development programs of the coming decades are being laid, but not in Germany. It's become clear that countries seeking global power must have the latest technologies at their disposal. Among the technologies transferred as spoils of war are items like the Flettner Colibri helicopter. The German aircraft now sports a US star. Technical renovations, like automatically extensible slats, are incorporated in designs, including what is known as the Kruger nose. And aircraft such as the Mir 262 are being put through their paces on test ranges in Texas. German propulsion technologies also give the US a boost when it comes to developing their own new aircraft. The Russians are also launching their confiscated A-4s. In 1947, researchers prepared to send one up at Kapustin Yar. German knowledge is being applied to achieve Soviet aims, saving trouble, time and money.
We were faced with the question of where and how we could continue the work being done in Germany, because the Cold War had already started. So we were ordered to go out and catch German rocket specialists.
The Russians form what are called trophy brigades in Germany. Their job is to find and take with them test benches and entire production complexes.
We built the next rockets within a year, using our own material, even though half of what we needed we didn't even produce then. It was difficult to do everything the way the government wanted it. And that was, namely, just the way the Germans did, but without using a single German screw. In 1948, we launched the R-1 rocket, which was an exact copy of the V-2. But we built it of our own material.
The R-1 is modified, but based on German findings. a whole missile series follows, culminating in the R-5 in 1956, which is capable of carrying a nuclear warhead.
They took all the technologies with them. The Americans and the Russians took them, intensively developed them further, and channeled those developments into their own industrial assembly and development. That's something that gets lost. Most only think of the A4 rocket. But everything that was involved with those technologies was exploited intensively by both superpowers. In my opinion, you can't really put a number on it. The sum they saved on development costs would run into the billions.
Human reparation is a post-war novelty. The Allies call it a peace dividend. They place German scientists and engineers in their service, in some cases by force. In the US, Werner von Braun is soon viewed as the most important POW from World War II. He and his team quickly come to dominate US missile research. In 1949, they test-fire a two-stage rocket based on the A4. It reaches an altitude of 400 kilometers.
It was almost from a standpoint of plunder in war, a unique moment in human history, because this was a case where science and technology was one of the greatest prizes that the Allied forces wanted to seize, after, obviously, the objective of winning the war militarily. And so there was a lot of improvisation going on, as people were saying, we really got to take these people, we really need to grab this technology. And part of this was the upshot that the United States took a lot more German scientists and engineers than I think anyone had ever anticipated.
What was started at Peenemünde continues at Redstone Arsenal in Huntsville, Alabama. German scientists used the V-2 design to create the Redstone rocket, which is first used in the Korean War. A decade later, it is also used to put the first American astronaut, Alan Shepard, into space.
It had a lot of influence. Of course, when you look at the first large American nuclear missile, the Redstone, that was very much derived from the V-2. The first satellite vehicle, which is shown in this hall, is derived from the Redstone, which is derived from the V-2, so obviously there's a significant amount of influence there.
US troops sift through the ruins in Germany looking for documents pertaining to Nazi aerospace research. Engineers from Boeing are also along for the ride. They make a sensational discovery.
The American experts immediately recognized the significance of this document. And George Schirra wrote a letter to Seattle right away. You can still read it in the archive at Boeing. In short, what the letter says is, throw away everything you've done up to now. We found a new wing in Germany.
A letter by the man who has become Boeing's chief aerodynamic engineer, George Schirra. The newly discovered German innovations lead to fundamental changes being made to the design of the new Boeing B-47 bomber. A bit later, engineers in the US begin working on innovative turbojets. In October 1947, an F-86 with swept wings makes its maiden flight. It's a spectacular example of the benefits of utilizing the fruits of German research. Just 2 months later, the first Russian fighter jet with swept wings, the MiG-15, takes to the skies. In Paris in 1955, treaties were signed that ended the occupation of Western Germany. Nearly full sovereignty was returned to the country. Now the watchword is progress. The West moves on to new well-being and a new lease on life. Even Germany's airline Lufthansa is allowed to return to the skies after a decade on the ground. The old research institutes already had a 2-year head start. By 1953, they had reopened and started work. The 1950s are a time for experimentation. 1954 was also a watershed year for new developments in eastern Germany. a heavenly stage was being set for a sensational presentation and competition for hegemony. The Soviet Union had held Brunolf Bade captive. In the mid-1950s, he unveiled the four-engine passenger jet, the Bade 152, in Dresden. But in the summer of 1959, the USSR refused to accept planes for use. The message was unmistakable. The development of civilian aircraft was to be terminated in Soviet-occupied Eastern Germany.
In the early 1960s, the German aviation industry moved into a new phase that lasted about a decade. They were working on an experimental aircraft that could take off vertically. Building an aeroplane that didn't need a runway to take off or land on had always been a vision.
April 1963 saw the debut of Germany's first vertical, short takeoff and landing aircraft, a fighter now known as the VJ-101. A high-wing aeroplane, the VJ-101's engines were located at its wingtips. They rotated from vertical to horizontal positions after the plane took off. The aim was to get into and out of the air almost independently of a runway.
But the vertical short takeoff and landing aircraft poses a particular problem when it takes off and still has no forward speed. It has to be stabilized because the rudders don't work. They only start working at a certain airspeed, but the aircraft isn't moving. It's hanging in the air like a helicopter. So it has to be kept stable, controlled and trimmed by other means. Trimming systems were developed that later benefited aircraft in the 1970s and 80s. The fruits of vertical start aircraft development in Germany could later be seen in the Tornado and in the German know-how that was applied on the Airbus, and can still be seen in the control systems that we use in the Airbus today.
Dornier's Do-31 is the only steel transport plane in the world that takes off vertically. Europe also wants to make it into space on its own. In 1962, a multilateral decision is made to build the Europa rocket, and nearly all the aircraft and engine builders want in on the project. Germany gets the job of making the technologically demanding upper stage, known as Astris.
Wenn ich mich jetzt recht erinnere,
if I remember correctly, the first technical experiment started again in 1959, because they could use the old classic big test and proving ground at Traun again. It was a big, complex compound, and it's very interesting. It came through the war unscathed, without losing a single screw. Starting in 1959, DFVLR engineers and researchers came back to the compound for the first time. They started to build the first test bench and re-equip the facilities that would later be used intensively by ERNO, the North Development Circle in Bremen.
The aeronautical engineer Eugen Zenger becomes the head of the facility at Traun. A German spaceflight pioneer, he had already designed the supersonic Silverbird spaceplane in 1943. The planned Europa rocket proved to be a flop, primarily because the French, British and German-developed stages failed to work together. After 12 unsuccessful launches, the program was curtailed in 1973. After Germany regained control over its airspace in the 1950s, work began on the first rotary wing aircraft. Test flights were carried out with new prototypes, but many of these designs remain incomplete. At the beginning of the 1960s, Dornier produces an unprecedented one-seater helicopter, but there's no market for small choppers. Meanwhile, several German firms, among them Borgward, are racing with one another to build the first practically applicable helicopter. New research complexes are built during that period. The DVL moves to Porzwan near Cologne in the late 1950s. Work also resumes in Braunschweig, in Göttingen, Oberpfaffenhofen and Stuttgart. In 1969, AVA, DFL and DVL merged to become the German Test and Research Institute for Aviation and Spaceflight, or DFVLR. The organization's aim is to make up for lost time by building on the successes that came in the decades before Nazi Germany's defeat. More than 2 decades after the closure of Peenemünde, Germany reset its sights on the stars. In 1969, Azur becomes the first German satellite to be put into orbit. The research probe is investigating the magnetosphere and the aurora borealis.
German policymakers declared in 1960 that they were not going to build and develop their own missile system. But they did say that they wanted to get involved in the satellite business. In 1962, Ludwig Bölkow wrote an exposé that called upon Germany to build its own satellite to show that it could do it. But what did that mean? Most of the components for satellites had to be obtained from the US. The Americans would also provide the rocket for the launch. That came to be known as the famous Azur project. Today it's known as the first national satellite, and it went down in history as the first project that intensively brought in industry, whether it was Dornier, Siemens or AEG, because they all supplied something. This marked the point of entry into the satellite business.
The success of Azur enables Germany to reach an ambitious partnership with the US. From 1974 onwards, Helios A and Helios B began studying the Sun. The twin solar probes were built in Germany, with the US taking responsibility for their launch. Both had an estimated life of 18 months, but continued sending data back from outer space for a decade.
2, 1, 0.
A technological dream comes true when the first supersonic civilian carrier makes its maiden flight at speeds of Mach 2. The Concorde premieres in 1969 and is hailed as a flying masterpiece. Development of the distinctive delta-shaped wings can be credited to Dietrich Küchemann of Göttingen, Germany. And Karl Dutch, working in Braunschweig, laid the groundwork for the aircraft's control system. But the Concorde remains a luxury model. Only 16 of the supersonic planes are built. Another aircraft will soon become the pride of Europe. The A300 is the first plane the Europeans build jointly, with the aim of challenging US dominance in the civilian aircraft sector. The Airbus is going to be more modern and economical. German political leadership attends the unveiling ceremony in Hamburg in 1974. Bavarian State Premier Franz Josef Strauß and Hamburg Mayor Hans-Ulrich Klose are on hand. The redivision of the skies has begun.
By the mid-1960s, they had managed to sort out a plan to get a joint project up and running in Europe. Politics and industry closed ranks at the end of the 1960s. Germany, France, Spain and Britain all said they were ready to join in and gave the world the Airbus. The company Airbus Industries in Toulouse in 1970 and the first project, the A300.
In 1972, the A300 is the most modern civilian aircraft of its time. Nearly 600 of them are built. 4 countries are represented in the consortium that builds Airbus. The division of labour is done according to expertise. The British build the wings, Germany part of the fuselage and the tail, and the French the fuselage interior and the cockpit. Assembly is in Toulouse. From now on, the name Airbus comes to symbolise flying as an everyday activity. Germany hosts the 1972 Olympic Games. It's the first time that the competition is being broadcast via satellite. Together with France, Germany joins in Project Symphony and tries to achieve independence from the US when it comes to commercial communications satellites. But the failure of the Europa rocket means they have to seek US help to put their satellite into space, and the US refuses to use its rocket for commercial purposes. To increase their political influence in the club of countries that have mastered spaceflight, Western Europe's nations formed the European Space Agency ESA in 1975. Their task is to promote the scientific and technological interests of its member countries. The first German to venture into space comes from the eastern part of the divided country. On August 26, 1978, Zygmunt Jähn hurtles into space on a Russian Soyuz rocket. For 7 days, Jähn carries out experiments aboard the Russian space station Salyut 6. Using a new multi-spectral camera, the MKF-6, he photographs the Earth. The new device sets the global technological standard for space cameras. East German experiments and technologies are also carried into space aboard Soviet space probes. East Germany is pursuing a small but technically ambitious space program. The Airbus family is growing, and with it a whole new series of technologies. A new concept for steering a plane comes to fruition with the A310. Fly-by-wire systems and a fully electronic cockpit pave the way for planes guided only by a pilot and a co-pilot. In 1972, DFVLR gets its own test aircraft, the HFB 320 Hansajet. It becomes one of the most important research aircraft for aeronautical engineering and flight guidance. The Hansajet is used to test a revolutionary innovation in guidance technology. In 1973, an in-flight test of fly-by-wire is carried out to ensure it can be installed in new models of the Airbus.
The signals go through a computer instead of going directly from the pilot to the rudders. That means the computer can be programmed so that it first recognizes the aircraft's limits and then observes them. So the pilot can't make it fly too fast or too slow. The plane won't do it, it corrects itself. And the cockpits of all the Airbus aircraft can then be nearly identical, including the indicators and instrumentation. The changes are only stored in the brain of the computer. The computer knows I'm sitting in an A340 or an A320, and in future I'll be in an A380. Except for small differences, the pilot is always confronted with the same cockpit.
The A310 is not only the most highly developed aircraft of its time, it is also the first civilian airliner in the world to have supercritical carbon fiber wings designed for airspeeds just below the speed of sound. The wind tunnels at DFVLR are used to carry out airflow simulations on supercritical wings. Tests of air resistance serve to develop a new wing template for passenger planes flying at higher altitudes at speeds approaching the supersonic range. The competition hots up.
The Airbus A310 marks the first time that a civilian airliner was equipped with this profile in Europe. The USA initially objected when this became common knowledge, and there were fears of a lawsuit based on patent violations. But fortunately, it was possible to prove that a German patent had already been issued for the technology in 1943. So the American claim was moot. If that hadn't been the case, there could have been legal problems with the A310.
Europe creates a sensation by getting into space on its own. The failure of the Europa rocket notwithstanding, the Europeans worked together to make their own booster rocket, resulting in one of the most successful carriers of all time, the Ariane.
We had to see to it that we were standing on our own 2 feet and became as independent as possible from the Americans, who were our main partner at the time. But they also knew that they would only succeed if we had the most important part as well, our own payload-carrying rockets. By the 1970s, we were able to build satellites on our own, without help from the US. Having components delivered from the US was no longer necessary. But if you wanted to launch them, then you needed to put something on the launch pad in order to be completely independent.
The first Ariane departs on its maiden flight from its launch site in French Guiana on Christmas Eve 1979. Never before has a launch been so smooth. Ariane is also alone at the top when it comes to commercial success. In the 1980s and 1990s, the Ariane 4 cannot be beaten when it comes to launching the world's satellites. Germany also joins the US space shuttle program. For the Federal Republic, it's the start of manned spaceflight. The European Space Laboratory is conceived and developed in Germany. Spacelab is tailor-made to fit in the Space Shuttle's cargo bay. Under German leadership, Europe's space program has a stroke of genius. Even though it doesn't have its own rocket for manned spaceflight, European astronauts are still able to take part in routine missions in space. The arrangement is unprecedented, as is Spacelab's status as the most ambitious project to date in the history of space science. On German astronaut Ulf Merbold's first flight in 1983, he accompanies Spacelab into orbit. Based on weight alone, Spacelab is packed with more instruments than any other previously launched European satellite. Never before have so many experiments been run on a single mission. By decommissioning in 1998, 16 missions have been run. During its 181 space days, Spacelab gave 110 astronauts a base from which to carry out 720 experiments.
Spacelab war ja sozusagen die Morgengabe.
Spacelab could be described as Germany's dowry.
Spacelab, wenn Sie das finanziell aufrechnen.
The Americans profited from it immensely if you estimate the financing. For the first time, we supplied what was going to be carried in the cargo bay of the space shuttle. The lab was completely integrated in the cargo bay. That gave German scientists and researchers a place to run their experiments. And the configuration has continued to work until this day. It's on the International Space Station as well.
Germany runs the D1 and D2 missions. Zero gravity research is the name for the new space discipline being promoted by Germany's political leadership. Germany uses Spacelab intensively. For the first time, operations within the shuttle's cargo bay are not led by the US. Instead, mission control is at the German Aerospace Center at Oberpfaffenhofen. On the 7-day flight, Ernst Messerschmitt and Reinhard Fuhr carry out research together with their colleagues. They orbit the Earth 110 times. The data gathered provides researchers enough material for years of exciting work. 75 experiments were carried into orbit on board D1. Among them were probes of the effect of zero gravity on biological and medical processes. In 1993, Hans Schlegel and Ulrich Walter take off on the D2 mission. The Europeanization of aeronautics research is also progressing. In 1980, the German-Dutch wind tunnel begins operation. Along with it, Germany takes a step closer to the pinnacle of global aviation research. Airflow tests are carried out on a model of the Airbus A340. Airbus planes have become serious competitors for those produced by the American aviation giant Boeing. Germany sets its course for the future of air transportation with the addition of the VFW 614 ATAS to its research fleet. Starting in 1986, the new aircraft gives German aviation research the first flying simulator. The plane allows researchers to gain insights that cannot be obtained by computer simulation. With the ATAS, the behavior of new plane designs can actually be simulated in flight. Carbon fiber construction technology ushers in a new age for aviation and a technological leap in international aircraft manufacturing.
This design has enormous advantages. The surfaces are much smoother than they would be if they were made of wood or metal. Above all, you can create shapes that are significantly more aerodynamic. Airbus started using carbon fiber instead of fiberglass with smaller surfaces, control system surfaces, spoilers, and then complete tail units. They had to use carbon fiber because of the need for stiffness. Airbus was a pioneer in this area. Airbus was the first company that made tail units completely out of carbon composites.
On November 9, 1989, the Berlin Wall comes down. German reunification brings with it the dawn of a new era for German air and space research. DFVLR becomes DLR. Times are also changing in space policy elsewhere, leading to intensive use of the Russian space station Mir by Western European astronauts. In 1992, Klaus-Dietrich Flade, a test pilot from the German Armed Forces, the Bundeswehr, goes into space as a research cosmonaut on a mission to Mir. Ulf Merbold follows in 1994. At this time, Germany in particular is able to profit from decades of close East German contact with Moscow. In 1995, Thomas Reiter goes on a space mission from a united Germany. He spends 179 days aboard Mir. It's the longest time a non-Russian cosmonaut has spent in space. Preparations for setting up the International Space Station, the ISS, are beginning. Reinhold Ewald also works aboard Mir in 1997. Together with Russian colleagues, he returns from space to land in the snows of the Kazakh steppes.
Rotate.
A corporate jet, the Falcon 20E, that belongs to the German Center for Aerospace Research, DLR, has been used for more than 3 decades to investigate aircraft emissions. The Falcon flies in the exhaust of a large passenger airline. Today, DLR has the largest fleet of research aircraft and helicopters in Europe. Research is also taking place to make planes quieter by minimizing the amount of noise aircraft engines make. A noise testing is carried out by DLR in cooperation with Lufthansa. New noise-reducing engine technologies and designs aimed at reducing noise from airstreams should make planes quieter. By the 1970s, growth rates for air traffic were already between 6 and 10%, and the volumes being transported have doubled every 10 years. As a result, economy has long since become one of the most important criteria for aviation.
Could you speed 220 knots?
At DLR's tower simulator, new technologies are developed and tested that are aimed at reducing the unfavorable aspects of increases in air traffic. By simulating traffic patterns in German airspace, bottlenecks can be detected early on and avoided. The most complex environmental research satellite of all times is being built at EADS, Astrium in Friedrichshafen. Envisat can multitask with the best of them and is the pride of German engineering. Since 2002, Envisat has been analysing developments above the polar regions, oceans and continents. On board is a German-Dutch instrument, Skiamaki, which can precisely detect trace gases in different layers of the atmosphere. That makes Envisat one of the most indispensable aids for monitoring compliance with the Kyoto Protocol and for crisis management. Data from space are often the sole sources of comprehensive information on local conditions after severe storms, floods or earthquakes. In 2000, German astronaut Gerhard Thiele joined the SRTM mission, the task of which was to produce a precise 3D map of the world. The German space technology sites are set further afield. In 1997, the Cassini-Huygens space probe was a joint European-US mission to Saturn and one of its moons, Titan.
And liftoff of the Cassini spacecraft on a billion-mile
It reached striking distance of Saturn in 2004. German scientists are also exploring the planets Venus, Mars and Jupiter.
Deutsche Forschung, hier die in den
The fruits of research done at German institutes can be found everywhere. Whether it's the Titan, or the landing of Huygens, or Cassini. Think about the Mars Express. That means we have very good linkage between research and industry. You have to remember to keep watering this plant conscientiously, because today we're in a position to be completely independent when it comes to spaceflight. We don't need to rely on help from anyone today. We can handle big projects by ourselves, thanks to the developments that began in the mid-1970s. We don't have anything to be ashamed of.
In the summer of 2003, Europe's first independent mission to another planet, the Mars Express, is launched. On board is a unique high-resolution stereo camera. Built at DLR, it enables the camera to create high-resolution images of planetary surfaces in color and 3D. The results have a much broader audience than planetary researchers. After 45 years of the closest cooperation in spaceflight, Europe is now on equal footing with the US and Russia. It is autonomous without insisting on autarky. After France, Germany is the second most important partner in building the Ariane 5. German engineers test the engines and design, develop and build the upper stage.
All spaceflight today is the legacy of German pioneers and the result of achievements made in Germany. Even now, Germany is developing technologies that are unique. After all, at ESA we have to know, because we publish pictures of Mars on the internet daily. These images come from an extremely precise, three-dimensional camera that was developed and built in Berlin. Rosetta is a small lander that's going to touch down on a comet in a number of years. It was also designed and developed in Germany. So the tradition is being kept alive, even when other countries contribute to the technological advances that are being made today.
2, 1, top. Allumage Vulcain. Correct. Paramètres bord, correct.
The sky's still the limit. With Europe's global satellite navigation system Galileo, the aim is to provide the world with reliable positioning information. A civilian project, the 30 planned Galileo satellites promise to be more reliable for users on the ground than the US or Russian systems. Through its many applications, whether it's in heavy traffic or the remotest of areas, the Galileo system demonstrates the immediate benefits of spaceflight for daily life on Earth. Since 1984, a number of countries have been pursuing the aim of operating an international space station. The end of the Cold War paved the way for the ISS project becoming reality. One of the greatest technological ventures in human history, it not only serves research, but promotes understanding between peoples. In 2006, Thomas Reiter became the first German astronaut to work aboard the ISS and outside the spacecraft. During the first long-term European mission on the ISS, Reiter carried out 33 European experiments. He's also the most experienced astronaut in the ESA crew.
The ISS is undoubtedly a moment in technological development that will last beyond this period. I see the point of this station less in a purely scientific sense than as a station that links political systems to one another. It's a station that led to international cooperation between East and West. And as a political symbol, it has already achieved a great deal.
A German-led team built the research laboratory Columbus as a successor to Spacelab. The new project also comprised Europe's contribution to the International Space Station. Mission control is based at the German Spaceflight Control Center at Oberpfaffenhofen.
Without teamwork, nothing can be achieved in spaceflight. Every engineer, every scientist, and every technician has a place on the team. An astronaut can only be in orbit because on the ground, hundreds of people are there who have trained him and who make it possible to monitor what's happening on the space station. Without every single one of those engineers, technicians and scientists, an astronaut is unable to do his job. Spaceflight operations intrinsically involve technical risk. They demand teamwork, and through this teamwork, everyone plays a key role.
Germany's position in there is very strong and frankly limited only by the German government's willingness to put resources into the enterprise. Let me say, Germany, of course, built the Columbus module, which next year, in '08, it's almost '07, in '08 will be flown up to the space station, and it will augment the research capability on the space station today by fully 50%. So, I mean, that's a tremendous accomplishment. In the early shuttle era, Germany was involved in the building of the Space Lab modules, D1 and D2. Looking to the future, of course, Germany is part of the European Space Agency, which has now for a long time been a partner in the U.S. manned spaceflight program. I hope that that will continue.
Built in Bremen, the Columbus Lab has space on board for 4 astronauts to carry out research. Commissioned by scientists on Earth, they will carry out long-term experiments in zero-gravity conditions. German astronaut Hans Schlegel will accompany the Columbus laboratory to the ISS. And one of the world's largest aircraft, the A380, is being cleared for takeoff. The largest passenger carrier on the globe is being readied for mass production. Aeroelasticity tests are being carried out under the guidance of the DLR. It's a test that every newly developed aircraft has to be subjected to.
Basic research is what we build on in industry. DLR's primary function is to work together with scientific institutes and colleges and so forth, who we then cooperate with in many diverse ways. We use their achievements and basic findings in applied research and incorporate them in technological developments. Without the work they do to begin with, we could never make our innovations a reality.
Germany is one of the world's leaders in the development of oscillation technologies used to test flutter in aircraft. The A380 is the pride of the Europeans and a prestige project, a new star in the skies, the most highly developed aircraft at the outset of the 21st century. Awe at the miracle of aviation is by no means a thing of the past. Since the infancy of motorized flights more than a century ago, taking to the skies has lost none of its fascination. German engineers and scientists have left their mark on technical and scientific progress in many disciplines. And air and space research continue to reflect the daring to make discoveries and eternal curiosity. The conquest of the skies continues.
I guess you're about the only person around that doesn't have TV coverage of the scene.
That's all right, I don't mind a bit.
Okay, you got the flag up now, and you can see the stars and stripes on the left.
Flag up now, and you can see the stars and stripes.
Are you getting a TV picture now, Houston? Neil, yes, we are getting a TV picture. You're in our field of view now.